Advanced technical drawing includes representing complex machine elements, gears, springs, and bearings, using standardized conventions. Full detailed drawings of gear teeth or spring coils would be extremely time-consuming. Conventions allow quick, clear representation of these elements in engineering drawings. Gears transmit rotary motion and torque between shafts. Gear teeth are complex involute curves. Drawing each tooth in full detail is impractical. Conventions, ISO 2203, are used instead. Spur gear terminology. Module, M. The fundamental tooth size unit. Module equals pitch circle diameter / number of teeth. Larger module equals larger teeth. Pitch circle, the theoretical circle on which the gears appear to roll on each other. Diameter equals number of teeth times module. Addendum circle, tip circle outer diameter of the gear. Addendum equals 1 1 module, above pitch circle. Tip circle diameter equals number of teeth plus 2 times module. Dedendum circle, root circle inner circle at the base of the teeth. Dedendum equals 1.25 below pitch circle. Root circle diameter equals number of teeth, 2.5 times module. Tooth thickness, half the circular pitch at pitch circle. Face width, the length, thickness, of the gear along the shaft axis. Gear drawing convention, the BECE ISO 2203. The addendum circle, tip circle, is drawn as a thick continuous line. The pitch circle is drawn as a thin chain, long short dash, line, centerline type. The dedendum circle, root circle, is drawn as a thin continuous line. Gear teeth are not drawn individually in assembly drawings, just the 3 circles. In a section through a gear, the teeth are shown in a simplified rectangular form, or often the section shows between teeth spaces. Meshing gears, in a drawing of 2 meshing spur gears. Their pitch circles are tangent, touching, at the pitch point. The addendum of one gear overlaps the dedendum of the other at the pitch point. Springs store mechanical energy and exert force or torque. Types. Helical compression spring, wound coil, compressed to store energy, pushes back when released. Used in vehicle suspension, ballpoint pens, valve springs. Helical tension spring, similar but pulled apart, in tension. Has hooked ends. Torsion spring, wound coil, energy stored by twisting. Clothespin, mousetrap. Leaf spring, multiple layers of flat spring steel clamped together, used in vehicle suspension or lorries, buses. Disc spring, Belleville washer conical disc, very high load capacity. Conventional representation of helical springs. Detailed, schematic, representation, draw the actual helical coil using 2 sets of parallel lines, showing outer and inner boundaries of each half coil. Simplified, symbol a zigzag line represents the spring. This is used in schematic diagrams. Detailed drawing procedure for compression spring. 1. Given, outer diameter, d, wire diameter, d, number of active coils, free length, end type, closed and ground ends for compression. 2. Draw the outer diameter rectangle, d times free length. 3. Draw the inner diameter, d, 2d. 4. The coils in the front half are solid, the coils behind are dashed, standard front view convention. 5. Ends, for compression springs, typically closed, the last half coil is flat, ground perpendicular to axis. Bearings support rotating shafts and reduce friction. 2 main categories. Sliding, plain, bearings, the shaft slides on a lubricated bearing surface. Simple, cheap, compact. Bush bearings, journal bearings. Rolling element bearings, balls or rollers between inner race or on shaft and outer race. In housing, rolling friction is much less than sliding friction. Types. Deep groove ball bearing, most common, can take radial and axial loads, quiet, high speed. Cylindrical roller bearing, higher radial load capacity than ball bearing. Taper roller bearing, takes combined radial and axial loads, used in wheel hubs, gearboxes. Thrust ball bearing, primarily axial, thrust, loads only. Self-aligning ball bearing, can accommodate shaft misalignment. Bearing designation, standardized numbers identify bearing type, size, and bore diameter. Conventional bearing representation. In a cross-section view, a ball bearing is represented by its inner race, outer race, and a cross X symbol indicating the balls. This is quicker than drawing each ball. WAEC question: draw the conventional representation of a spur gear. State the names of the 3 circles drawn in this convention. Explain what is meant by module of a gear. Conventional spur gear drawing. Draw 3 concentric circles. 1. Outer, addendum/tip, circle, thick solid line. 2. Middle or pitch, circle, thin chain, long short dash, line. 3. Inner, dedendum/root, circle, thin solid line. Do not draw individual teeth, unless specifically asked for tooth details. 3 circles, addendum, tip, circle, pitch circle, dedendum, root, circle. Module, the ratio of the pitch circle diameter, in millimeters, to the number of teeth of a gear. It is a measure of the size of the gear teeth. Gears that mesh together must have the same module.